Okay, this is your Chapter 6 review. I'm going to start with number 1 and 2, obviously. And in this review, I'm going to shortcut a few things only to make sure that I can get through it pretty quickly. If you have any further questions, make sure you ask Miss Parker or me tomorrow or Tuesday in class. So number 1, you were supposed to graph the equations for 1, 2, and 3. And you were supposed to determine whether it was infinitely many solutions, one solution, or no solutions. And if it's one solution, you were supposed to name it, which means you'll get an ordered pair or a coordinate. So number 1, I went ahead and solved for y. So you should have gotten y equals 2x minus 3, and you should already notice that if my first equation is y equals 2x minus 3, and my second equation is 2x minus 3, then that is the same line. So that's going to give me infinitely many solutions. And I'm going to write that first. But we do want to graph it too. This is great practice for graphing linear equations like we did last chapter. So I'm going to go to -3 on my y-axis, and my slope is +2, so up 1 over 2, up 1 over 2. And on your paper, you can definitely use a ruler and make it nice and straight. I'm going to try to connect my dots and make it as straight as possible. Notice that I always make my line go all the way through my plane. So it goes off of the plane, and there's my line. So obviously, since it's one line on top of the other, every place they touch. There's no place they don't touch. The next one, the first one is solved for y for us. The second one I solved already. So when you solve for y, you should have gotten y equals -3x plus 9. So I'm going to go ahead and graph both of these. I should know that they are going to cross in one place because their slope is different. As soon as I have a different slope, I know they're going to cross somewhere. So I'm going to graph the first one. So I'm going to go to 4 on the y-axis. And then my slope is up 1 over 1, up 1 over 1. And let me go ahead and do this one first. You do not have to make that many lines. I am just to help myself make this line straighter. And so here is our first line. And then our second line is y equals -3x plus 9. So this is 9. Should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here. I'm going to go down 3 over 2. I should already see my cross spot, which I do. Go ahead and make a few more dots so I can make it a little bit closer to being straight. Eyeball it. Okay, and so right here is where they cross, so that's one solution. And the solution is 2, 6. And if to make sure I could plug that in, if I plug in a 2 here, 2 plus 4 is 6, that is correct. 2 times 3 is 6, plus 6 times 2 is 12, 6 plus 12 is 18, so it makes both of those equations true. Now let's go on to number 3. This one has not been solved for us yet, but when we do, all you have to do is subtract the 3x from both sides, and you'll get y equals -3x minus 2. I should notice that my slopes are the same, but my y-intercepts are different. That tells me these are going to be parallel, but I'm going to graph them just to make sure. So I'm going to graph the first one. I go to -2, and my slope is -3, so down 3 over 1, down 3 over 1. I go the other way, up 3 left 1, up 3 left 1, 3 left 1, and so I'm going to have a line, oops, it's a little curved up at the top. That's okay, so there's one line. The other one's going to go through the origin, and it has the same slope. So I'm going to up 3 left 1, up 3 left 1, up 3 left 1, down 3, down 3, down 3. Okay, and so you'll notice they're very close. And my lines are not perfectly straight, but these slopes tell me that they are perfectly straight, and so they will never cross, so this is a no solution. Number 4. It asks you to do 4, 5, 6, 7, and 8 by using substitution, and on the test we will not tell you really which way to to solve. We'll give you suggestions, but if you'd like to solve a certain way, you certainly can. But on your review, we do want you to practice both ways. When it is solved for a variable already, it already makes it nice and easy for us to substitute. And I've told you, those of you that have trouble, put parentheses around it, so that way I know anything in parentheses is equal. Okay, so y and 3x are interchangeable, so that means I can interchange this y also with a 3x. So I'm going to get 2x plus, I like to put parentheses around what I substitute, plus 3x equals 15. So we get 5x equals 15, and x equals 3. And we're not done because remember we have to get a coordinate, so I plug it back into one of my originals. I'm going to plug it into the first one because that just seems a little bit easier. So I'm going to get y equals 3 times 3. And so y equals 9. And so your answer will be 3, 9, which is your coordinate. Okay? And to double check, you could check it in the second one. So 3 times 2 is 6, plus 9 is 15. So yes, that is true. Number 5, we're going to do the same, only this time instead of substituting for y, we are substituting for x. So everywhere we see an x in the second equation, we're going to plug in y minus 7. So I get y minus 7 plus 8y. Notice now all I'm dealing with is y, so I can actually solve for the variable. I don't have x's and y's anymore. So I get y plus 8y is 9y. So 9y minus 7 equals 2. And then I add 7 to both sides. So I get 9y equals 9, meaning y equals 1. I'm going to go ahead and get a different color to show you the second step. So when I plug y back into one of my originals, and I'm going to plug in the first one just because it's already solved for x for me. So x equals 1 minus 7. Well, 1 minus 7 is negative 6, so x equals negative 6. And so your answer is negative 6, 1. Make sure to put your x in the x coordinate spot and your y in your y coordinate spot. And that is done. So number 6, they are both solved for y, so there's two ways you can think of this. One way is to do exactly like what we've been doing, is to put parentheses around what equals the same thing, and then I'm going to substitute in for y. So this is going to now become in there. That's going to become y. Or that they're both equal to y, so if these two amounts are both equal to y, then we can make them equal to each other. It's going to give you the same result. So negative 3x plus 12 equals negative x minus 2. And so I'm solving for x, so I'm going to add 3x. Doesn't matter which side your x's go to. I like to make my x's positive if I can. And I'm going to add 2 at the same time, so I can do two things at once. Okay, so that way these drop out as well. So my resulting equation is going to be 14 equals 2x. So x equals 7. And again, we're not done. We always have to plug that back in. It doesn't matter which one I plug it into. I'm going to pick the second one this time because it's just got smaller numbers. But again, it doesn't matter which one. If you always like to pick the first one, always pick the first one. So y equals negative, and I'm going to put 7 minus 2, excuse me. So I get y equals negative 9. And again, just to plug it into the other one, if I plug in 7 here, I get negative 21 plus 12 equals negative 9, and that is true. So my answer here is 7, negative 9. So that's the first 3 in substitution. Let's do the last 2. Okay, this one's solved for x. So everywhere I see an x in the second equation, I'm going to plug in this value, and this will cause us to do a little bit of distribution, but that's okay. We know how to do that. So we're going to get 4 minus 5y instead of x, because that's the same value as x. We're plugging that in here, just so we understand that. Plus 15y equals negative 1. So I get 12 minus 15y plus 15y equals negative 1. If you'll notice, These two amounts right here, my y's are going to cancel because negative 15y plus 15y is 0. That's the additive inverse property. So I get 12 equals negative 1. Don't panic. Whenever we get something like this where all of our variables drop out, it means we're either going to get no solution or all solutions. And this is a false statement, so that means this is a no solution. Okay, because 12 will never be equal to negative 1. Now in the next one, we're going to do the same thing. So I'm substituting in for x. And I'm going to get 2 times 4y plus 1 minus 8y equals 2. So I get 8y plus 2 minus 8y equals 2. Again, if you'll notice, our variables are going to drop out here because 8y and negative 8y goes to 0. That's additive inverse, and I'm left with 2 equals 2. Well, this time that's a true statement. So that means this is one of those infinitely many solutions. That means any point that's on one line is on the other one, meaning they touch every place. This is the same line. It's just different ways written when they gave it to us. Infinitely many solutions. Okay, now let's go on to elimination. These are all already set up for us. Mostly, we might have to do a multiplication here or there, or add or make that decision of adding or subtracting. Here, my x's are nicely lined up. My y's are my equal sign, most important, and my constants. So we're going to drop out our x terms. So I'm going to get x minus x, same sign, subtract. 2 minus a negative 3, and if we need to, let's go ahead and put parentheses to make sure we remember all of these things are being subtracted. So I get 5y equals 6 minus a negative 4 is 10. Y equals 2. Again, we're not done. Doesn't matter which one I plug it into. I'm going to go ahead and plug into the first one. So I'm going to get x plus 2 times 2 equals 6. So that's going to be subtracting 4 on both sides. So I'm going to get x equals 2. And just plugging back in here. So 2 minus 3 times 2, which is 6. 2 minus 6 is going to give me negative 4. So that's a true statement too. Just a nice quick check to make sure I've done my calculations correctly. And I got 2 as my coordinate. Number 10, if you'll notice, they're all lined up. My equal signs are lined up, constants, y's, and x's, but nothing will drop out if I add or subtract, meaning I'm going to have to multiply one or both of these to make something eliminate. So I want my x's to eliminate because that way I only have to multiply the top one by 3. If I eliminate my y's, I'd have to multiply the top by 5 and the bottom by 2. So we're going to go ahead and multiply by 3. I'm going to rewrite it below. So I get 3x minus 6y equals 15. And we're going to subtract since they are same signs. So we get 5 minus a negative 6y, so that's really plus, so I get y here, equals 8 minus 15, which is negative 7. So already done with solving, y equals negative 7. Then I'm going to plug it back into one of my originals. I'm going to plug it into the top one just because the numbers are smaller. So I get y minus 2 times negative 7 equals 5. So I get x plus 14 equals 5. So x equals negative 9. And make sure again that when you put your answer together, it should be negative 9 comma negative 7 because that's my x term and that's my y term. It is not negative 7, negative 9. Okay, number 11. Same thing. I'm looking for something that will drop out. And this time I cannot easily multiply just one to get to the other. So I'm going to multiply both. And in this case, I'm going to multiply my x's. If you wanted to multiply your y's, multiply the top by 5, bottom by 2. I'm going to multiply the top by 3 and the bottom by 4, only because that will allow me to have a 12 and a negative 12, and that way I can add them because we've been subtracting up to this point, and I want to give you an example of addition. So when I rewrite these, the top one, let's write it down here. So I'm going to get 12x minus 6y equals 96. And then on the bottom, I'm going to get negative 12x minus 20y equals negative 44. Okay, and so now I'm adding because these are opposite signs, so that goes away. So negative 6 plus negative 20 is negative 26y, and then 96 plus a negative 44 is actually 52. So I get y is negative 2. Okay, after all that. Then I'm going to plug that back into not one of these, but one of the originals, just because those numbers are smaller and I know I won't make a mistake with these bigger numbers. I'm going to pick the first one. So let me get a different color here. 4x. I meant to get a different color. Try that again. 4x minus 2 times negative 2 equals 32. So I get 4x plus 4 equals 32. So then I get 4x equals 28. So x is going to be 7. So my answer here will be 7 comma negative 2. All right, so each of those came out to 1 point, and it will be a coordinate. Let's look at 12, 13, and 14. Okay, these are lined up pretty nicely. I want to do another addition. If you wanted to remove your x's, you subtract. If you want to remove your y's, you're going to add. So I'm going to go ahead and add to get rid of my y's first. So I get 2x equals 12. So x equals 6. Plug it back into one of your original problems, and get 6 plus y equals 10, meaning y equals 4. That one was pretty nice and easy, so 6 comma 4 is my answer. 13, again, I can drop out my x's or my y's. If you want to subtract, drop out your x's. If you want to add, drop out your y's. And depending, if I want to drop out my y's, I multiply the top by 2. If I drop out my x's, I multiply the bottom by 3. So let's go ahead, since we haven't done one of these in a little while, we'll multiply and we'll do a subtraction. So I'm going to multiply the bottom one by 3. I get 3x plus 6y equals negative, let's see here, 108. And then if I'm going to rewrite the first one underneath here, so 3x minus y equals 11. And so I'm going to subtract, remember, so 3x minus 3x is going to be 0. Subtracting this whole thing. 6y minus a negative y is actually a plus y, so that's 7y equals negative 108 minus 11, so that's negative 119. Okay, and then I'll divide both sides by 7, and I should get y equals negative 17. Then I'm going to plug that back in, and this one looks a whole lot nicer to plug into for y than having to multiply that negative 17. So I'm going to get 3x, let me grab a different color, 3x minus a negative 17 equals 11. And so that's really 3x plus 17 equals 11. And we're going to subtract 17, and we get 3x equals negative 6. And so x is going to be negative 2. And so your answer on this one should have been negative 2 comma negative 17. And number 14, same thing. They all line up, especially my equal sign. That's really important. However, nothing will equal the other one just by multiplying one of them. So I'm going to have to multiply both. And because my numbers on my y are smaller, I'm going to go ahead and use those. But you could certainly do the x's. It really doesn't matter. It's your preference. So I'm going to multiply the top one by 3, the bottom one by 2. When I rewrite the first one, I get 15x plus 6y equals negative 9. The second one, I'm going to get 6x plus 6y equals 18. And then when this drops out, I get, and remember we're subtracting, and if you need to put the subtraction sign in the parentheses, so 15 minus 6 is 9x, and then negative 9 minus 18 is going to give me negative 27. So x is going to be negative 3. Then I'm going to plug it back into one of my originals, and I'm going to pick the second one. So I'm going to do 3 times negative 3 plus 3y equals 9. I didn't change colors. Let me go ahead and do that for this part of it. So I get negative 9 plus 3y equals 9. So I get 3y equals 18 and y equals 6. So my answer here, my coordinate is negative 3, comma 6. Right? All right. Then the next section, it said that you could pick whichever way you wanted to, which really we've been teaching you the whole time. So hopefully you're looking at it and saying, what's the easiest strategy for me? To me here, whoops, on this first one, it's already set up for elimination. My x's, my y's, it's in standard form. My equal signs line up. Everything lines up. And I have opposites here, so I'm just going to go ahead and add. That's the easiest way to solve this. It's not the only way, but to me that's the easiest because it's already set up. So I get 5x. My y's cancel, equal 20. And so I get x equals 4. Not done. I have to plug it back into one of my original equations. I'm going to plug it into the first one, so I get 3. Let's use a different color. So I get 3 times 4 minus 5y equals 7. So 12 minus 5y equals 7. We'd subtract 12 from both sides. We get negative 5y equals negative 5. So y equals 1. So your solution here is 4, comma 1. Number 16. Don't be fooled here. Yes, my x's line up. Yes, my y's line up. Yes, my constants line up. But look where your equal signs are. They are not lined up. So either you can subtract y on both sides and make them line up then so your equal signs are lined up. You can certainly do that, and you'd get x minus y. Here would be the equation if you want to do elimination. X minus y equals 1 on top. However, since they're not that way right now, the way that I would solve it, I didn't mean to do that. The way that I would solve that is to go ahead and do substitution because one of our variables is already solved for. So everywhere I see an x, I'm going to be plugging in y plus 1. So I get y plus 1 plus y equals 3. So that's 2y plus 1 equals 3, 2y equals 2, and y equals 1. Now that I have my y value, I can go ahead and solve for my x value, and I'm going to plug it into that first one. So I get x equals 1 plus 1, and so x equals 2. Be very careful where you put your x and your y. X term is 2, y term is 1, so 2, 1 is my solution on that one. Number 17, again, this is set up. My equal signs are nice and lined up, and my 6x and 6x will drop out if I subtract. So I'm going to go ahead and subtract those. So 6 minus 6 is 0. 5 minus a negative 7 is 12y, and 4 minus a negative 20 is 24. So y equals 2. We're not done. We're going to go ahead and plug that back in to find out our x term. It doesn't matter which one. I'm going to go ahead and pick the top one. So I get 6x plus 5 times 2 equals 4. So I get 6x plus 10 equals 4. So 6x equals negative 6. That's from subtracting 10 on both sides if you have to see that. And then x equals negative 1. So my solution here is negative 1, comma 6. Okay, and now let's move on, excuse me, to 18 and 19. This is another one of those, they're both equal to y, so the way I think of it is if they're both equal to y, then we can set them equal to each other. So I get 4x minus 1 equals 2x minus 5. And now when I solve for x, I'd subtract 2x on both sides, and I would add 1 on both sides. And so I'm going to go ahead and get 2x equals -5 plus 1 is -4. So x equals -2. And then when I plug it back in, oops, and that's a negative. When I plug it back in, and it doesn't matter which one, I'm going to pick this one just because that's only multiplying by 2. So I get y equals 2 times -2 minus 5. So that's -4 minus 5, right? And so y is -9. And so your answer here is -2, -9. 19, again, they're lined up for elimination. However, it is not set up for me, so I'm going to have to multiply both. And I'm going to multiply the top one by 2 and the bottom one by 3, just to make it a little bit easier on me because those numbers are smaller than 2 and 5. But you could have multiplied by your x terms to get rid of those, which would have meant you multiplying the bottom one by 2 and the top one by 5. So when I rewrite, I get 4x minus 6y equals 42. And this one will become 15x minus 6y equals 75. And I'm going to subtract. And so when I do that, I get 4 minus 15, which is -11x. And then equals, is that right? 4 minus 15, yes, -11x. And then 42 minus 75 is going to be something I need to look up. So let's see here. 42 minus 5 equals -33. So that means that my x has to be 3. Make sure I did that right. Yep. Okay, and then I'm going to pick one of these to plug it back into. I'm going to plug in the first one, only because I have to multiply. It's less to multiply. So I get 2, and we'll do a different color. So 2 times 3 minus 3y equals 21. So 6 minus 3y equals 21. And 21 minus 6, so -3y equals 15. So y is going to equal -5. And so my solution here is 3, -5. All right. Now, on any of those, you could have solved them differently, but if you got the same answer, that's what counts there. You just have to come up with that same coordinate. So now 20, 21, and 22 are all word problems. So we're going to be setting up the equations ourselves and solving, but the solving part we've already done. We've done several of them already. So I'm just going to read my equations and write them down. This is going from verbal to algebraic. We've done this before. So twice a number, so that'd be 2x plus 3 times another number, so that's 3y, equals 4. So there's your first equation done. Then 3 times the first number plus 4 times the other number is 7. So there's your two equations. And if you look here, it's obvious that I'm going to have to multiply both of them. And so to save us time, I'm just going to write what I'm going to multiply each of these by and then rewrite them over here so I can solve. I want to get rid of my x's just because that's a 2 and a 3 instead of a 3 and a 4. So I'm going to multiply the top by 3, and I'm going to multiply the bottom one by 2. And when I rewrite them, I get 6x plus 9y equals 12. And on the bottom, I'm going to get 6x plus 8y equals 14. Since I have same signs, I'm going to subtract. And so these cancel. 9 minus 8 is 1. And 12 minus 14 is -2. So I already know that one of my numbers is going to be -2. Now I need to find the other number. And if you wanted to be perfectly correct. You know, this is my second number, so if you wanted to put it in the second slot, but it does, since it does not say what's the first number and what's the second number, it does not matter what order you put them in here, since this is not an ordered pair on a coordinate plane. I'm going to plug it back into one of my original equations. I'm going to plug it back into this one right here. And so I'm going to get 2x plus 3 times negative 2 equals 4. That's an equal sign. So 2x minus 6 equals 4. So 2x equals 10, because I added 6 to both sides. And so x is going to be 5. And so my two numbers are negative 2 and 5. Okay, so those are my two numbers. Let's go ahead down to the number 21. And if you tried 21 and were frustrated, here's why, because I did the same thing. There is a typo on our review, so I apologize for that. This should be, instead of 937, because there's no way to solve it like that. There really isn't. You'll get a negative number for one of the numbers, and we can't sell a negative number of tickets. So this should be 337, not 937. 50. Okay, and then it'll be able to come in nice for us. So adult tickets for a school musical sold for $350 and student tickets sold for $250. 321 were sold altogether for $337.50. How many of each kind of ticket were sold? This one's not quite as easy to see the two equations, only because I don't read the first sentence and have one and the second sentence and have one. I have to use all the information together. And anytime you have something like this with tickets sold all together, you're always going to have one that is the amount of tickets and one that is the amount of money. And hopefully that will help you. So the first equation I'm going to do is go ahead and say, well, how many were sold all together? It says 321 were sold all together, and there were adult tickets and student tickets. So you're always going to have one, and I'm going to use A and S just because that's easy to me. So A plus S, the amount of tickets, equaled, and it says 321. So that's going to be one of the equations. That's the amount of tickets. The other one is going to be money, okay? So adult tickets were $350, so that's going to be 3.5, and you could put 350A, that's fine, plus 250S, because that's how much each student ticket cost, right? And then that's going to equal the total amount that we made. So that's your two equations. This is an easy one for substitution. And so when I substitute, I'm going to solve for one of the variables, and I'm going to go ahead and solve for S, just because. So that means I'm going to subtract A from both sides. So my substitution is going to be S equals 321 minus A, right? Because I just subtracted A from both sides. And now one of my variables is solved for, so I can plug it into the other one. So when I solve it, I'm going to get 350A plus 250 times 321 minus A equals 337.50. So all I did, so now all I should see is one variable, and so all I see are A's. I no longer have A's and S's, so I can solve this. So I get 350A plus 250 times 3, is it 321?